It's time for Chapter 9, Section 7, Independent and Dependent Events. Alright, so the first thing we need to talk about in this section is the probability of two or more events happening one after another. Let's take a look at that. So the probability of two or more events happening can be found by multiplying the individual probabilities of each event. Let me give you an example. Let's say you were rolling a number cube and flipping a coin. And I wanted to know the probability that you would roll and get a 6, then flip the coin and get tails. Well, we know the probability of getting a 6 when you roll a number cube is 1 out of 6. And we know that when you flip a coin, the probability of getting tails is 1 out of 2. What we're going to do is we're going to multiply these two probabilities. Numerator times numerator, 1 times 1 is 1. Denominator times denominator, 6 times 2 is 12. So the probability of getting a 6 when you roll a number cube and then flipping a coin and getting tails, the probability of both of those things happening in that order is going to be 1/12. Alright, next, since the name of this section was independent and dependent events, let's talk about what they are. So, independent events, they're events where one outcome does not affect the other at all. Whatever happens with the first event has no bearing on the probability of the second event taking place. So with the example we just looked at, when we rolled the number cube and we flipped the coin, well, rolling a 6 did not affect the probability of getting tails at all. If we get a 6, that doesn't mean all of a sudden we're going to get tails when we flip the coin, or if we rolled the number cube and got a 4, it doesn't mean we would get heads all of a sudden. Rolling the number cube is completely independent of flipping the coin, so one has no bearing on the other whatsoever. Next, let's take a look at dependent events. So, dependent events, they're events where one outcome affects the next event. It affects the probability. The easiest way to show you this is with an example. So, let's say that we have a bowl of fruit. It's got 3 apples and 1 pear. And I want to know, what's the probability that Carla will eat an apple and then another apple if she's choosing the fruit randomly? So imagine she's sitting there, she's either blindfolded or not looking, whatever. She just reaches into the bowl of fruit, doesn't even know what she grabs something, eats it, then reaches in, grabs another thing, and eats it. What's the probability that she will eat an apple and then another apple? So, the question would look like this. Probability of an apple and then an apple. So, when she first reaches into the bowl of fruit, there are 3 apples and there's 4 total pieces of fruit. So 3 out of 4 is the probability of her grabbing an apple. Well, once she grabs an apple and she eats it, the second time she reaches in there for an apple, the probability is not 3 out of 4. Now there are only 2 apples remaining and there's only 3 pieces of fruit in this bowl. Remember, she reached in, she took an apple out. That lowered the total amount of fruit from 4 to 3, changing the denominator. Likewise, since she ate an apple the first time she reached in, when she reaches in the second time, there's only 2 apples left. So see how this probability was dependent on the action that took place in the first event. Again, we multiply these probabilities. 3 times 2 is 6. 4 times 3 is 12. This can be reduced to 1 out over 2. So that means there's a 50% chance of this happening in this situation. That is dependent events. Let's take a look at another example. Okay, let's suppose the next day Carla's going to do this again. Again, we have another bowl of fruit. Again, there's 3 apples and 1 pear in it. And she's starting fresh. What's the chance that she's going to reach in and the first thing she eats is an apple and the second thing is a pear? Well, again, when she first reaches in for an apple, the probability of getting an apple is 3 out of 4. 3 apples out of 4 pieces of fruit. Next, when she reaches in, the probability of getting a pear. Well, there's still 1 pear there because she did not eat any pears. However, the denominator is still decreased. There's only 3 pieces of fruit because she already ate one when she ate the apple. So again, this was dependent on this, dependent events. 3 times 1 is 3. 4 times 3 is 12. And this reduces to 1/4. Alright, that's everything for this section. See you in class.